Every second, millions of transactions happen across the world. Money moves, contracts are signed, data changes hands. But here's a question nobody asks. Who's keeping score? Right now, a bank, a government, a company you've never heard of. But what if nobody had to? What if trust didn't need a middleman? That's exactly what blockchain was designed to solve. And by the end of this video, you'll understand it better than 99% of people. Let's start with a simple problem. Imagine you want to send $100 to a friend in another country. You don't hand it to them directly. You call your bank calls their bank. Fees get taken, days pass, and somewhere in the middle, someone you've never met decides whether your money moves or not. That middleman, whether it's a bank, a notary, a clearinghouse, exists for one reason: trust. We don't trust strangers, so we pay someone to be the referee. Blockchain asks a bold question. What if the system itself was the referee? What if you could trust the math instead of the man? Okay, so what actually is a blockchain? Let's break it down word by word. Block. A block is just a container of data. Think of it like a page in a notebook. On that page, you record information: who sent what to whom and when. Chain. Each new page is attached to the previous page, permanently and in order. You can't rip out a page without everyone noticing. You can't change what was written without breaking the chain. That's the core idea. A blockchain is a shared notebook that records transactions, can never be edited, doesn't belong to any single person. Now, instead of one bank holding that notebook, imagine thousands of computers around the world all holding an identical copy simultaneously. If someone tries to fake a transaction, their version doesn't match everyone else's. The network rejects it automatically, instantly. No manager needed, no help desk, no headquarters, just math. Let's walk through what actually happens when you make a blockchain transaction. Step 1. You initiate. You say, I want to send 1 Bitcoin to this address. That request gets broadcast to the network. Step 2. The network validates. Thousands of computers, called nodes, check the transaction. Do you actually have that Bitcoin? Is the math correct? Is the signature valid? If yes, the transaction moves forward. Step 3. It gets grouped into a block. Your transaction gets bundled with other recent transactions. This block is given a unique fingerprint called a hash. Step 4. The block joins the chain. Once verified, the block is added to the chain permanently, linked to the block before it, sealed forever. Step 5. You get confirmation. Done. The transaction is complete. No bank approval, no business hours, no 3-day wait. The whole process can take seconds to minutes, depending on the network. Here's where it gets really interesting. Traditional systems are centralized. One point of control, one point of failure. Hack the bank, you can alter records. Hack the government database, you own the data. Blockchain is decentralized. There's no single server to attack. No CEO who can quietly change the rules. No one country that can freeze your funds. The network exists as long as any computers are running it. This isn't just a technical feature, it's a philosophical one. It means ordinary people can participate in financial systems without permission. It means agreements can be enforced without lawyers. It means records can be trusted without governments. Some find that revolutionary. Some find it terrifying. But it's happening either way. Now, most people hear blockchain and think Bitcoin. But Bitcoin is just one application, like saying the internet is just email. Here's where blockchain is actually being used right now. Supply chain. Walmart uses blockchain to track food from farm to shelf. If there's a contamination outbreak, they can trace the source in seconds instead of days. Healthcare. Patient records stored on blockchain can't be altered, lost, or stolen. Your medical history controlled by you, not a hospital system. Real estate. Property transfers that used to take weeks of paperwork can happen in hours. Smart contracts execute automatically when conditions are met. Digital art and ownership. NFTs, love them or hate them, proved that digital items can have verified ownership. The technology itself is legitimate, even if the hype got messy. Voting. Researchers are testing blockchain-based elections that are transparent, auditable, and tamper-proof. The common thread? Anywhere you need trust without a middleman, blockchain has a potential role. Now, I'd be doing you a disservice if I only told you the good stuff. Blockchain has real limitations. Speed. Traditional databases process thousands of transactions per second. Some blockchains still handle dozens. Scaling is an ongoing challenge. Energy. Bitcoin's proof-of-work system consumes enormous electricity. Newer consensus mechanisms like proof-of-stake are far more efficient. Complexity. It's hard to use. It's hard to recover from mistakes. Send crypto to the wrong address? It's gone. Forever. Regulation. Governments around the world are still figuring out the rules. The legal landscape is shifting fast. Blockchain is a powerful tool, but like any tool, it's not magic, and it's not for everything.
So, here's what we've covered today. Blockchain is a shared, permanent, tamper-proof record maintained by a network instead of a single authority. It removes the need for middlemen in transactions, agreements, and data storage. It's already reshaping finance, healthcare, supply chains, and more. And it's still early. Whether blockchain becomes the backbone of the next internet or just a useful tool in a bigger toolkit, understanding it now puts you ahead of most people. If you want to go deeper, the next video covers how Bitcoin actually works and what gives it value. Hit subscribe, and I'll see you there.